Well, welcome. I hope you're overall enjoying the conference and finding it worthwhile. It's different. Pat Coppett wrote a LinkedIn post talking about how it was different, but I hope that's different in a good way to what you normally experience. So, at any rate, what we're doing today is talking about a little bit more about learning science. And what I have to find out here is I can't find the share your screen link. It must be right. Oh, there it is. Sorry about that. Cheerios. So we have indeed this position, and just gonna talk a wee bit about it and ask for your reflection. I suppose before I dig in, any questions that emerge for you or any issues you want to discuss before we get going? And small enough group, you can use the mic, you can use the chat. I will open up my chat window.
Is this the point at which I admit that I haven't done the homework?
Well, you're not the only one. So it's okay. It just some of it. So we'll rehash some of the underlying principles, but we're not rehashing the actual going through the experiments yourself. So
of course,
you'll have missed that. Any other questions, comments, or issues? You know what I should do? Is I wonder if I can do this on the fly. I can. Excellent. All right. I had the wrong camera up. I've been on several different calls today. And as you were mentioning, Scott, switching between calls and switching between cameras and microphones and everything, and keeping me on my toes. I'm just back because I had that trip to India and I came back for a week with a vicious cough, and then I was at Devlin last week. So I'm still catching up on stuff. But that's TMI. So I hope the conference is going well, and this is day 3. And any other issues, comments, questions before we begin? Thoughts? All right. Anytime as we go along, we have probably more time than we need. The first thing, sort of the first thing we covered was models. And I think we don't do enough to recognize the importance of models. So I'm going to dig a little deeper. And in one of the revelations that's been happening in cognitive science is beginning to understand this model of cognition that's called predictive coding. Lisa Feldman Barrett, in her book, How Emotions Are Made, actually does one of the clearest explications of this, because some of the original stuff from the guy in the UK, and I'm going to draw a blank on his name, is a little bit impenetrable, and some of the mathematics is quite impenetrable. But what they point to is a model that says our brain is continually running subconsciously, making predictions about the world, about what's going to happen. And it does that. It builds models, somewhat statistical models, but models nonetheless, that explain how the world works and gives us a basis for making these predictions. And when we're correct, we're fine. But when we're not, that's not fine. And it triggers either we act on the world to make it consonant with our expectations, or we learn. And really, that's what drives learning. But it's that, and you're doing it right now, listening to me, not consciously, but subconsciously, that's what happens. Now, there's some interesting variation around that, because that would suggest that what our brain would want to do is sit in a nice, warm, dark room where nothing could happen, so we wouldn't have our expectations violated. But we do know that we go out and search out certain types of experiences. We do challenge ourselves. We do things like escape rooms where we don't know the answer when we start. We go to movies where we don't know what the story is going to be. Sometimes we rewatch movies for little surprises, violate our expectations, but we do violate it. But then there are things we absolutely avoid trying to have change. So the question is, what makes it different? And I'm going afield from learning here, but I think this is interesting to think about. My suggestion is, when the threat of being wrong is lower than the thrill of experience, we do it. That's why movies are safe, escape rooms are safe, amusement parks should be safe, novels are safe. We can do these things, and we like to learn. In general, we just don't want to learn in ways that are too traumatic. Anyways, that's what our brain is doing, but it's building models of the world. And there's some interesting phenomena in research on mental models. And up here on my shelf, one of the first books I ever got, my colleagues got me, the Gentner and Stevens book, Mental Models, as a gift when I left work and went back to go to grad school. And there's some robust results about models. And the first one is that we're continually building them. Naomi Miyake did some interesting work with sewing machines. People know how to use them, but almost nobody actually understands how they work. And they try and build models, and it turns out to be complex because there's a thing flying around underneath that actually picks up the thread and manages to wrap it around itself without doing damage. It's really strange and magical. But she did research and found out that people do build models. And if our models are wrong, we're very resistant to giving them up. We don't go, please, sir, may I have another model? Instead, what we do is we patch our existing model. And if it's still wrong, we patch it some more. And you end up with this Frankenstein's monster of a patched together model, which isn't accurate still. So I take the implication of this is that we should give people models. When we're helping learners perform, there are pretty much always models involved. Our subject matter experts may have trouble articulating that. A little bit later in the chapter we went through, we talked about how experts compile their knowledge away. It's literally not accessible to them about how they do things. Their knowledge they have access to, the explicit knowledge, but how they actually do things is compiled away. So we have to unpack that. Anyway, so the models we want are causal and connected. Why do we want that? We want them connected so they make a coherent whole. We want them causal because they're a basis for prediction. I will suggest that what's going to make a difference to your organization is not remembering more and better facts. I'm going to suggest it's the ability to make better decisions. And models give us that basis because with a model, we can mentally simulate the outcome. We have this causal model that's predictive and explanatory. It can explain what happened. It can predict what will happen. And so you can say to yourself, if I do this, this will happen because you're running the model. And if I do that, that will happen because you're running the model. And then you can say, this is better than that, so I will do this. That's a basis for making decisions. And most everything we do, whether it's a procedure, there's a reason you do it in the order that ends up being the prescribed mechanism. For making decisions, there's a basis upon which. In the diagram I'm showing, I'm suggesting that a model is a conceptual, related, predictive, causal story. And there's a context, and you can map part of that model to the context. And our brains are actually pretty reasonable at this. They will map, although they tend to map surface features a little bit harder to get more abstract. It really helps to make sure the model is useful. And then if you do match it, you can make a prediction from the model and figure out what's going to happen in the real world. That's the third step there in the diagram. By the way, that diagram is a causal conceptual model. It explains what happens and how we use models, right? But that's the point to using models, is that they give us a good basis. And I want to suggest that, again, finding good models is difficult. Finding ways to represent them. When I talk about engagement, when I talk about models, I say there's little that's engaging about a model. All you want to do is make it as minimal and as useful as possible. It's not like there's stuff we can do. that we should, but it is useful. So emotionally, we should open the experience with an introduction, activates relevant knowledge and hooks them in with the WIFM. Then we should provide them with models. And then the next step is we provide them with examples, but then we give them practice. But the concept guides the behavior in the example and should guide us in our practice, and the feedback should explicitly refer to it. That's what I wanted to say on models. Any questions on that before I continue?
I was going to
As
add,
we're
I
going
think this
through,
is really,
sorry,
I was going to
go
add,
ahead,
I
Rich.
think this is really important. I find it in my work where we often take a formulaic approach to addressing certain problems. It's like, here's an organization that has an issue in their culture. Let's pull a few things off the shelf and give them these experience. And where I keep getting frustrated is, how do these things connect? Like, if we do something about coaching, how does that connect to our understanding about the social dynamics in this group and what's happening there and what's the effect this is going to have? And it's a constant frustration. Like, I want to start with, like, how do we understand how the system works? And then once we understand it, okay, now we can start to do things that influence the system. But I have a hard time getting my colleagues to kind of step back and look at that big picture.
Right. Yeah, and that is an issue sort of below, not below, above just what we're talking about, but it's absolutely important that beginning to look at things in terms of systems is really critical, because you can't tease it apart and deal with it separately. You yank on it, and as John Muir famously said, you find it's connected to everything else in the world. Models are a simplified story about how the world works. They're deliberately constrained to give you useful predictions in this instance. But yes, you should understand how it connects in the broader picture. For most of learning, we're trying to give people relatively rote things, but increasingly, yes, as things are complex, and as Matt works with Nigel Payne and a couple other colleagues on leadership, they point out that it's so contextually bound, you really need to understand it in context. And is there anything we can abstract? I think there is, but that's how I roll. But I thank you for that, support. I absolutely agree. And I think when we see people being given useful models to make decisions, they perform better. In fact, Arun Pradhan and his colleague, who I'm drawing a blank on in Australia, made a whole site just about a whole bunch of different mental models. And that's one of the things I do. I sort of collect mental models and have them to hand to pull on when I see and map to something and go, oh, this model looks like it maps and it's useful. And then it may activate other related models that also are helpful. But I think you're right that we can worry about models out of context instead of in context. Thank you for that. Any other? By the way, as we're going through this, you should be continually thinking, what does that mean I would do differently? What do I have to do? And if that leads to any barriers, we'll ask those questions at the end, but be thinking about it. All right, in conjunction with models, and this wasn't in the video and should be, and I need to add it, but examples. Examples take those models and place them in context. And typically it's a story where I've got this problem, I'll try this, and you get an outcome. And in fact, you should tell it in the form of a story, because our brains are wired to comprehend stories. It should explicitly refer to the model. How do people understand how the model plays out in context if they don't see it and see it being related explicitly? Ellen Schoenfeld takes it even one step further. Before I go there, one of the things, again, experts don't have access to what they do. So they'll go, oh, first you do this, then you do this, then you do this. And the learner will go, oh, okay, I do that. That makes sense. That makes sense. And then they'll face a problem on their own and they'll be stuck and they'll think they're stupid. And they're not. What the expert doesn't have access to anymore is, well, first I could do this, or that because of this feature, I'm going to do this. That thinking behind it isn't shown, and you really need to show the thinking. And then here, I could have gone here, but because of this, I went here. All that stuff is really valuable for the learner to hear, because that's stuff that they will need to internalize themselves, and yet the experts don't have access to it. So it's hard. Another thing that Alan Schoenfeld did, so he made that clear, and that's part of, that was his contribution in a sense to cognitive apprenticeship. Alan Collins and John Seeley Brown, with two different authors, one with Ann Holem, the one I like better, and another one with Susan Newman, a little less accessible, but still great. Looked across several cognitive tasks. Reading, writing, and arithmetic were sort of the quintessential cognitive tasks. And they pulled in the work of Anne Brown and Anne-Marie Palingsar on reading and reciprocal teaching. They pulled in the work of Marlene Scardamelia and Carl Bereiter about writing and scaffolding, and the work of Alan Schoenfeld on examples and modeling, and pulled it together and abstracted a model which was heavily influenced by looking at apprenticeships through, as John Love and Etienne Wenger used to talk about, and really mapped it to what made effective education. And if you look at educational theories, they're dynamic. So David Merrill, for instance, went from component display theory to ID2, and now he's at Pebbles in a Pond. Most of them have trajectories as other people have results they need to incorporate. I think they're going to end up where cognitive apprenticeship already is. Anyways, so cognitive apprenticeship, one of the things is examples. And what Alan Schoenfeld did, in addition to modeling that underlying thinking, he would actually deliberately, because he was smart enough, he didn't need to do this, so he had to do it deliberately. He would introduce an error and skip past it and keep working down, suddenly go, this can't be right. And he would look at, and he would find some way to demonstrate, like an order of magnitude error in the numbers. That can't be right because of this. And then he'd work back, he'd find the error, he'd fix it, and then work forward again. He didn't do this because he was dumb. He did this because learners really benefit from seeing that self-monitoring and correction. Experts don't like to make mistakes. Yet, for instance, the average airline pilot makes several errors an hour. That's from research a number of years ago, but I believe it's still true. We have some randomness in our architecture. We don't do things by rote repeatedly. We make mistakes. Fortunately, the systems in airplanes are robust enough to handle this. And I'm sorry you now know this, but trust me, doesn't keep me from flying, all right? What keeps me from flying is other people in the airplane, in the airport. But flying is fine. But we make these errors, but by showing them, he's helping learners understand that experts are continually self-monitoring, or should be, and checking for real-world validation of where they're going, and seeing that they make errors too. And if it's okay for experts to make errors, then it's okay for the learner to make them as well. And so as part of that is creating a culture of learning where mistakes are not only understood, but even expected. So, and a good example can include that. We have to work. The good thing is, so subject matter experts are struggling, and how do we deal with that? We're going to have to triangulate data. It's getting several people I know who did lots of good work with experts, and this includes Guy Wallace, this includes Roger Schenck, this includes Norman Beer. Talk about doing it in a group. If you can get a group of experts together and get them to negotiate a shared understanding, they have to articulate the underlying thinking. And when they do, their other fellows will correct it until they get to what actually happens. So if you can work with the subject matters in a group and facilitate the dialogue so they come up with a shared answer, not you. That's not always possible, and not everybody's a good facilitator of this. There are some other techniques you can use. You can talk about decisions and ask anytime they want to dump knowledge, say, what decision does that enable? Focus rather on decisions. You can ask specifically beforehand with questionnaires to get that in, and be smart about it as well. When you read the PowerPoints and PDFs, do some inference of what really has to be important in actually applying this. That's challenging as well. But when you triangulate, you increase the likelihood that you're going to have something that ends up helping unpack what's going on. Not every subject matter expert is able to articulate this. So don't, if one's not working for you, find another. Don't just be, and I know in the real world, you're sometimes stuck with that subject matter expert. That's who you have. But if you can, go out and read, Google search, web search. I don't like to use Google anymore. I don't use Google. I use DuckDuckGo. But the point is, one other point to make. And when we had John Swaller on You Ought to Know, he made this point, and it really, I had known this, and yet I hadn't known it explicitly. He said, particularly for novices, after you give them the concept, a few worked examples before they do practice is more valuable than just immediately jumping into practice, which is sort of counter to what you might think, that, immediately give them problems and they can start solving it. Actually seeing worked examples, and worked examples are the ones where every step includes the thinking behind it, and all the labels are integrated and things, so it minimizes cognitive load. It really helps learners. So another reason to think of examples. By the way, I separate out motivating examples that I use in the introduction to help people viscerally understand the what's in it for me, from a reference example like this, which you can actually refer to. And if you're solving a very similar problem, you can actually use these sorts of examples as actual guides, whereas the motivating examples don't have enough detail to do that. I think that's all I have to say on examples. Any questions on that? By the way, your subject. Oh, go ahead, please.
Sorry. Yeah. Hi. Yes, I have a question about when to introduce models in a course of instruction. So my general understanding has been that it's better to basically get a learner to arrive the model through examples, rather than just introduce a model and have that be the first thing they see and then do worked examples. But maybe that varies depending on the level of the learner or the kind of instruction given. And so I guess I was just wondering if you had any thoughts about when is an appropriate time to introduce a model, especially if the model is more theoretical nature.
Yeah, and you're right. I do think it depends. And I actually don't know the best answer to this. I do believe that, if there's a clear, explicit model that helps them, you could do it, give it up front. If you do, then you need to give them a worked example that shows it in context. You really shouldn't show a model in isolation without any real world reference, or it's just going to sit as some abstract thing that they arbitrary, which our brains are really bad at remembering. Making it causally connected helps, making it coherent. Now, I have developed demo content that we did in the Workplace for the Future where we didn't present the model explicitly. We immediately plopped them into a problem-based learning. Now, these were not just novices by and large. These were people with some knowledge of the real world. So we gave them the problem, and then the model was available in the problem. So in other words, you could open it up there. Suddenly you know why it's relevant. Now you really need to understand it because it's going to help you make decisions, right? That sort of motivates it. I think if the model's complex, though, you might need to explain it enough so that when you see it in the experience, we don't totally take you away from the experience. You can just refer to it. So I think it also depends on the complexity of the model. As I was suggesting, also the expertise of the learner to begin with. The more they're expert, the more it can be available on demand as opposed to being explicated officially. The more complex it is, the more likelihood I think it needs to be explicated explicitly. Models may even be built. They may not be comprehensive at a whole. You may show the simple version of it first and then start complexifying it. For instance, dealing with difficult people, you might start with just the simple model of repeat back what you've heard from them so they feel heard. And then you can start adding it, if they seem to want to be wound up about this, and everything you say is going to trigger them do something differently than if they really want a solution. You know, you gradually build it up. And that would be with worked examples and with practice as well. So it's interleaved. But yeah, I think it's sort of a judgment call in the first instance. Make a good call, test it.
Great, thank you.
Does that help?
Yeah, that's really helpful. Thank you.
No worries. And the one, you know, subject matter experts are difficult to pull models out of. And also they're really important for misconceptions, the alternatives, the ways people go wrong. They're better for examples because they probably have good stories about big wins and big losses. And you want to pull those out when you're dealing with them as well. They may not want to talk about their own losses, but they can probably tell you some stories of someone else in the company or someone else in the field who had a disaster by not correctly following the practices. So you want to get those stories because those are going to make your examples and might even form the basis for some of your practice as well. So don't forget to get stories from them. Any other questions on examples? Okay. One of the things in that section was about putting knowledge in the world instead of in the head. Our brains, as I've already suggested, are pattern matchers and meaning makers. Our brains are also really bad at remembering rote information, abstract information, arbitrary, large quantities of abstract rote information. And we're really bad at exercising rote processes repeatedly without error. That old time and motion studies, scientific management, the Taylorism stuff, people were literally cogs in a machine and they were exercising that. Increasingly, we are able to automate that stuff and we keep our brains for what we should do. And as wonderful as our cognitive architecture is, it's allowing us scattered in different parts around this country or the world. We can come together and share. Despite the amazing things we can do with our brains, there are just some flaws. There's no one architecture that's going to be all singing, all dancing. By the way, what our brains are really bad at, remembering arbitrary, rote, large amounts of information, exercising repeated processes. Computers are the exact opposite. Computers can perform, they're really hard to get to do pattern matching and meaning making. Until recently, it used to be that they had to do that, have a connection so they could go out to a server where that could do it better and come back. Recently, they've put that capability on the phone because they've built in some specific pattern matching chips. But even then, it's pretty rote stuff compared to what humans can do. But we have these certain limitations. We have sensory store limitations, dissipates really quickly, but we can use things like recorders and cameras to record that stuff that our brains don't do well. We don't remember all the details, photos do. We have limits on attention, so we can have notifications, reminders, so we don't miss appointments and things. We have working memory limits, but we can use calculators or external representations to store intermediate representations. We have recall limits. We don't recall things absolutely perfectly, but we can look them up. We can have search and put the information in the world. We skip or forget steps repeatedly, particularly if it's something we do again. Toll Gawande's wonderful book, The Checklist Manifesto, documented how just a simple checklist, developed after a lot of testing and refinement, was able to switch the mortality rates in third world surgery from 80% to 20%. That's a fabulous turnaround. And it goes on. Biases, we can use lateral prompts to keep us from setting into things like set effects. Premature evaluation, we can get data and things to keep us from converging on a belief that isn't backed up. We can use templates to keep us from fatiguing and things. We have a lot of external tools we've used to accommodate gaps in our cognition. And this includes our design processes, by the way. There's a reason why proper brainstorming works and regular brainstorming doesn't. regular brainstorming brings everybody together, shows them the problem, and they immediately start talking. You need to think about it individually first to get the benefits of thinking about it differently before you bring people together. But we have a lot of practices and ways to put information in the world to scaffold our cognition, and thinking that it all has to be in the head is one of the major problems we have as an industry. I argue that we have this belief that we're formological reasoning beings, and therefore, if we give people new information in the form of bullet points, they'll change their behavior, which isn't true. And we have to put everything in the head, and we can, if we put it all in the head, then we'll perform perfectly. Instead of recognizing that a lot of what we do is in the world. You know, why do we have spreadsheets? Because we can't remember all these formulas and numbers, and yet they augment our thinking. So 2 takeaways for this from me, 2 takeaways from this for me are that we should put information in the world when we can, and we should design for augmenting our thinking. Okay. Spreadsheets for fun. Cool. Question about when you use models, right? Model thinkers are too occupied to read the emails. Yeah, I stopped getting them too. Sorry, I noticed I wasn't paying attention to the chat, so I've just been caught up. Yeah, spreadsheets for fun. You put in ideas and stuff and ways to keep track of ideas for travel, for, you know, I don't know about you, I use external representations to support traveling. I have a checklist for packing. I mean, just external memory, even for fun things, not just work things. So any questions on that? Thoughts, issues, comments?
Could you elaborate just a little bit on a lateral prompt? I've not heard that term before. Was
Oh,
that
right.
something that you deliberately use to compensate for a potential bias?
I don't enough, but that was one of Edward de Bono's things. Really interesting. He sort of came up with connectionist models before they were popular, but he immediately took them and ran to the direction of what does that imply for facilitating creative work. But one of the things he talks about with the 7 thinking hats, and those are sort of lateral prompts, look at it from this way, look at it this way, look at it this way. It's shifting you out of your perspective. But there are also tools inspired by him, and he may have been involved in some of them as well, where as you're getting ideas and you're deliberately juxtaposing. So if, you know, so if Aaron has an idea and I have an idea, and we've come up with them separately, we come together, we share, and we say, what would the intersection be? Is there anything there? That's being lateral, deliberately using a process to try and create more ideas before we converge. But they also had things that would generate random ideas that you would mix in. So you might run this thing and it would say purple tennis shoes. And then you'd be required to think, what would purple tennis shoes mean for our solution? And it's just a way to actually keep us from prematurely converging, because our brains do tend to, for instance, if we solve the same problem several ways, I mean, if we solve several problems the same way, let me say that right, Clark. If we solve several problems the same way, we're more likely to solve the next problem that way, even though that may not be the best solution process. And similarly, we tend to see tools as used one way and don't think outside the box about how it might be used in another way. So one of the classic problems is 2 pieces of string, you have a screwdriver. Turns out, and you can't reach them, and yet you're supposed to tie them together. And if you tie the screwdriver to one and set it swinging, so it's a pendulum weight, not a screwdriver, it then comes closer to you. You can grab it while holding the other string, and then you can tie them together. We have these ways that limit our thinking, and lateral prompts are a way to break out. Any other questions on that? We mentioned context last week, but it came in this week in the video. So my apologies for getting that wrong. So I'm not going to spend a lot of time, but I'm just going to briefly say, if the area of transfer that your learner needs is to a situation like A, and you've practiced in only the blue O's, your likelihood of transfer to A is pretty low. So that's, for instance, you are practicing negotiation with vendors, and then comes up a situation where you need to negotiate with your boss for a salary raise, you might not bring any of that knowledge over. But if you've done broad, the red X's are your contexts that you use for practice and examples, you're much more likely to transfer to A. And that would mean, you practice negotiating with a vendor, you practice negotiating with a shopkeeper, you might even practice negotiating with your kids. You're not supposed to, and you do anyways. But the point being, you want to make sure, and I'm wrestling with a client with this right now, apparently it's more problematic concept than I thought, to get your mind around covering the space of possible applications and choosing the minimal set that will support transfer to all appropriate situations and no inappropriate ones. But that's the underlying idea here. I know we covered this last week for those who were here, and I'm trying to think, I think the 2 people who were here last week are none of the people who are here this week, so it's not too much of a problem. Is this any questions on that? Interesting. Erin mentioned that in the chat, she mentioned that on the previous slide, externalizing information is helpful for neurodivergent learners. That's fabulous. Making things, using cognitive augmentation to support our thinking in any way for anybody is a good idea, but I'm glad if it has proven useful for that. Rich says, oh, he's weighing in with that. Yes. I'm not an expert on neurodivergent learners, even though there's considerable evidence that I was probably ADHD when I was young. Before we had that as a label, my friends would always go, Clark, you're so hyper. Oh, now I know. And I'm still kind of obnoxious, but as if you hadn't noticed. But anyways, that is not anywhere near the full definition of neurodivergent, but as we're exploring it, we're finding many interesting ways in which people cope and which representations and support can help. So I think that's fabulous. And I do encourage you, Rich, to encourage your wife to explore that, because, and she may well know. I think that's cool. So I'm really glad to hear. Any questions on context or choosing examples and practice? By the way, the red X's or the blue O's are the context seen in both examples and practice together. If you see a worked example in a context, and if you do a practice in a context, they're both establishing those spaces that you transfer from. The goal here is to abstract from those contexts and create an understanding that can be transferred to a new context. From the O's, you're going to abstract relatively narrowly and transfer relatively narrowly. From the X's, you're more likely to abstract more broadly and be able to transfer more broadly. If there are funny hiccups in a particular domain, or establish the base that everybody needs, and there may be some hiccups there. Otherwise, if there's certain things that certain people are going to need because they go off in this direction. So for instance, you might take product knowledge. Everybody might need the base knowledge about what this product does, who it's for, whatever. Salespeople are going to need to know a bunch more about how it compares to the competition. Technical people, troubleshooters or support teams may need to know a lot more about how it operates. That's how you differentiate what examples and practice people might need, depending on their role. But there's probably is a shared understanding that everybody needs about it, and you just want to make sure you understand the space. Okay, I've gone on a little bit too far on that. Any other questions? Okay, I'm trying to get better about waiting long enough that if somebody does have one, it'll emerge, because otherwise, if you speak too fast, you keep them from saying it. Of course, I hope you know by now that it's far better to ask the question than to not. Okay. In all that stuff, is there anything surprising or interesting for you that we can unpack a little further? Okay. Accept representations helping neurodivergence. That may be new and exciting. What can and are you going to do differently? This is one I really want to hear your answers to. Because I hope you're going to do something differently.
I can speak to that. I think for me, I don't work directly with the authors who create our learning content, but I think from my experience viewing the content and knowing how we create content at where I work, I think it's really important to I think two things stuck out to me, namely including like mistakes or including correction. I don't know how often our instructors are really doing that as they're working through worked examples. And I think that can be something I can take back. And then another thing I think would be as far as including worked examples or practice opportunities that really widen the scope of what a learner can do in an actual like test application, or like being for them to be able to have like a broad context so that they can more readily apply in novel situations. I think is a delicate balance to strike, because I know with our authors and with the way that we create content, we want to create content that is relevant and that it feels in line with the kinds of learning objectives that we want learners to achieve. And so what you said about making sure that you're including like the minimum number of practice examples that will enable them to succeed in all the situations, without doing any that like are inappropriate, basically, or so. Yeah, figuring out how to balance that, I think, is something that I don't think, at least where I am, is talked about enough. So because I feel like we're often balancing between like an author not giving enough examples or going so far out there that learners are like, why is this relevant to me? So yeah.
Okay, well, you remind me, by the way, in talking about the first one of your two elements, misconceptions are really important. When we make practice, one of the important things is having the right level of challenge. It's got to be, if it's too simple, no learning happens. If it's too difficult, no learning happens. It's got to be tuned to their level of ability. One of the good ways to do that, and important for principled reasons, you want to have the alternatives to the right answer, but ways that people actually go wrong. That raises the level of challenge and it gives you a chance to address it. Now, I mentioned that we have some error in our cognitive architecture, some randomness. That's evolutionarily advantage, because if we do it differently one time, just randomly, and if it's better, it may get rewarded, and gradually we can learn a new thing. That's true for animals as well as people. But most of our mistakes are patterned. They tend to be reliable mistakes because they're based on misconceptions. Kurt Van Lane used the example of subtraction, and you could figure out what their misunderstanding was by the numbers they came up with. Instead of just being random, you'd tend, if you didn't carry, if you always subtracted the large number from the small number, no matter which order they in, and didn't carry, you'd get one answer different from the right answer. And if you did that but did carry, you'd get a different answer. So there were certain patterns of mistakes that were reliable and indicated a specific misconception. You want to build those first of all, you need to find those out. And that's one of the reasons I like to triangulate on the performance objective, not learning objective, performance objective, what people need to be able to do, not what they need to be able to know. Is not just the subject matter expert that knows the model that guides it in perfect performance, but also the supervisor who oversees people actually performing this and goes, no matter what you do, they still make this mistake. That's wonderful now, because that's a reliable misconception that you want to figure out what its cause is, make it available as an option in the learning experience, and specifically address it, which is also, by the way, why any authoring tool that doesn't allow different feedback for every wrong answer is broken. We don't see that too often anymore, but it's wrong. The alternatives to the right answer should be reliable ways people misunderstand stuff, and you should then provide specific feedback about why that particular approach is wrong and what the right answer should be. So misconceptions are an important part of what you also need from subject matter experts. Besides the models, besides the stories, you need the misconceptions and their consequences, by the way. What happens if you get it wrong versus what happens? You should get the consequence of getting it right and the consequence of getting it wrong based on these specific misconceptions. So you can make that available as an option and then diagnose it and debug it. One other thing, by the way, you can get from your SMEs, we'll maybe talk more about this next week, is most of the time they seem like an enemy. They're hard to get to. They can't tell you what they actually do. They want to do a knowledge dump. They want to avoid you. They want to just do it their way. They think they know what good teaching looks like, et cetera, et cetera. But there's something they've done that's very valuable to you. And that's they have spent the hours to be an expert in this. What is it about it that made it so interesting to them that they decided to pursue this as potentially a career? Or certainly have put in, the 10,000 hours myth is debunked, but they've spent a considerable amount of time to be relatively expert on this. Why? What is that? If you can pull that out of them, I'll tell you a story. I had designed games for my first job before I went back to college. Before I went to grad school, I designed a game based on my PhD research. I designed a game for kids who grew up without parents because I was asked to. So a colleague at the university asked me, I'm designing a game, would you like to help? I said, sure, what is it about? He said, computer auditing. And I thought, I'd rather have my teeth pulled without anesthesia and convey this. And he said, that's what I thought. But then I talked to them and they said, it's like playing detective. There's a mistake and you work your way backwards. Most of the time, it's just an error. But every once in a while, it's deliberate. They had the story right there for the game. Somebody did it deliberately. And they ended up putting in, the guy did it deliberately to get back at the bank because he was working out because they fired his mistress. And it's just, but you have the story. There's something about it that's interesting to them. Find out what that is, bake that in. That's what takes it from just being straight learning science to an experience. That, to me, is what really separates. All right. But thank you for sharing what you can do differently. And I think also it's hard. We tend to just think about examples as, oh, let's just provide a few stories instead of thinking deliberately, how are they going to facilitate making sure that we get appropriate transfer? When you do that, that extra effort pays off. So I encourage you on both those fronts. Thank you for mentioning that. Anybody else?
So I think I'd like to actually go back to the previous question, which is, what was interesting about, surprising or interesting. And I think one of the things that's coming to the top of my brain, listening to this whole presentation session, is the applicability of all of these things that you're talking about in process design or system design. So it's not just applicable to the learning environment, but it's everything that you're calling out is equally the things that you need to be cognizant of, the things that you need to bring to the fore when you are thinking about designing a process that allows people to go through templated approaches or checklists, that whole kind of thing of when you want people to be doing something the same every time, or not necessarily doing something the same every time, but getting the same or a reliable outcome through process design or systems implementation, everything that you've talked about here is as applicable as it is to the learning design or content design that you are primarily talking about. And that for me is really interesting to watch unfold.
Well, it is. I was steeped in grad school in a group that was about user experience. And so they were designing interfaces. My twist on it was designing learning experiences. They were designed for how people think. I designed for how people learn. But I have on my editorial soapbox, I have a belief that the three things everybody needs to know to be able to be effective in the world and business is they need to understand technology, what it can and can't do, and understand its core affordances, which we'll be talking about in the other session I'm doing for the conference. They need to understand design, how to systematically overcome those errors in our cognitive architecture, how we use tools and practices and policies and processes to get around that, to come up with the best outcome despite our limitations, and the cognitive architecture that underpins it all. If you understand people, you can design for them, and everything we design for pretty much involves people. So you need to understand what we covered last week more than this week, that human information processing loop, the attentional limitations, working memory limitations, the process of elaboration, retrieval, and how what emerges in our consciousness is a combination of the context we're in and what we have learned before that together. We'll explore that more next week, by the way. But yes, absolutely. I think that if you understand what we're talking about, what we're adding is that learning layer on top of it, but the core, I think, applies to everything humans do pretty much.
Yeah.
As Herb Simon was quoted, to design is human. So, I like it. All right. Last question. What do you fear you can't do differently, even though you know this now? What barriers might you face in putting this in place so that we have a chance to potentially find any, find and eliminate any barriers collectively between all of us, if anybody was facing something they might be challenged with?
I can't remove all the irritating people that I have to work with.
Well,
so if you can show me a way to
vision.
do that.
Yeah. Dealing with difficult people, I once had to bake that into a course I was designing. And I looked up and, difficult people, well, passive aggressives, you just tell them what you need. Negotiators, you have to give them something in return. The dominator, you have to, I forget what it was, but dealing with difficult people is a reality of life. But selling them on helping them get a shared commitment to the vision helps break down some of those barriers, for what it's worth. Reset it costs. Anybody else?
I think on some, depending on the organizational culture, sometimes that with SMEs or just the business in general, having them make that leap from learning or seeing learning only as an information dump, right? And that is so deeply embedded in some places that trying to, you have to show examples. It's doable for sure, but sometimes the hills are a lot steeper in some places than others, because there's the embedded culture of, hey, it's on the 700-page PowerPoint deck. You went through it, you learned it, or it's in, we have 15, 20-minute videos. And the point that you were looking for was, well, no, it was in there. It was at, 5 minutes into video 7 was the one point you needed. It's good enough. That's all you need. It's like, not really, right? So, and it's difficult. People get really calcified in that because it seems easy. It seems obvious, right? And I think that's the challenge of the SME, the expert. Like, this stuff is obvious. Why don't you get it? Well, you've spent 18 years working in this space, and it takes people, we know as learning folks that there's a process to get there. So it's harder in some places than others, and it depends a lot on organizational culture. So.
I agree. And one of the things I recommend strongly is have a suite of different types of responses. So have a story, like remember how how difficult it was to learn to drive a car initially, how long it took you until you could stop thinking explicitly about how much to push the gas pedal and how much to push the brake. And you could just start thinking about going and stopping instead of all those details. Also have the theoretical principles to hand, the scientific evidence, have, draw them out about something they learned that, they care about, like whatever sport or hobby or whatever they have. Be prepared to have a variety of approaches and find the one that works. But yeah, be prepared for and that holds true for other things. I know we're getting to the top of the hour relatively quickly, so I do want to just briefly tell you, chapter 4 is just a sort of a closing video for me, but go do it anyways, and go do anything you haven't done yet already. It doesn't take long. I mean, I think anybody who's gone through it can tell you. Next week, I want to go into some stuff that's not in the course. I want to talk about I gave a talk recently on sort of, we're still stuck in the mentality that we're these formological reasoning beings. And even if we're not consciously, it's still indicated in our practices in the organizations. I want to give several frameworks that are sort of post-cognitive, the ways we realize we're not formological and ways of thinking about that give us some very explicit prescriptions for what we should be doing practically in terms of our practices. And then talk about what it all means and we can go further into the design process and some going forward thoughts. So that's what we're covering next week. I hope to see you there. I think there's some additional fun stuff, and that will wrap up Learning Science 101 for this conference. But of course, there's plenty of ways to find out more. Any questions on that? Otherwise, I'm going to, sorry?
Thank you.
Okay. Well, I'm going to stop sharing. I'm going to exit my presentation here. I'm going to put this camera over here so I'm looking at the right place, hopefully. And I'm going to stop the recording. Thank you all for your